Have you been wondering lately about moving on from your preferred 8-bit microcontroller? If so, the MSPM0 from Texas Instruments might be on your radar. But what's the best way to get started? The first interaction with a microcontroller for many engineering students today is with an 8-bit device, but these can be quite limited in terms of performance, features and memory. So what's the alternative, and is there a way to quickly get from idea to running code? To find out today, I'm chatting with Alex Grudzinski from Texas Instruments about their MSPM0 32-bit MCUs and their zero code development environment. Hi Alex, and thanks for joining me.
Hi, Stuart. Thank you for having me. I'm really excited to work together today.
And I'm really so excited to talk to you as well, because one of the things I wanted to talk about was the engineering students that I meet. There's those that have just started their careers and they've normally tried at least one of the available single board computer or SBC platforms. And I find, especially with the entry-level boards that feature an 8-bit microcontroller, they quickly run out of performance, features or memory, or often all three. Now, back in March of 2023, Texas Instruments introduced the MSP0. That's a new family of general-purpose 32-bit Arm Cortex M0 Plus microcontrollers. And they've got some really impressive on-chip analog peripherals as well. So tell me, what is the overall scope of the MSPM0 family?
Yeah, of course, I can definitely help with that. Our MSPM0 Arm Cortex M0 Plus microcontroller portfolio scales all the way from CPU frequencies of 24 megahertz up to 80 megahertz. On the flash memory side, it goes from 8 kilobytes of flash up to 512 kilobytes of flash. And on the pin count, it goes from 8 KB up to 8 pins up to 100 pins. And in this case, there's various levels of analog integration, and it's fully pin-to-pin hardware and software compatible between all the different devices. So you truly only have to pay for what you need in this case.
Now, since that announcement, I think I was looking on the website, there's about 100 different devices have been released. And if you go on the website and take a look, you can see they're sort of categorized into different target application spaces, I think I would call it. How do you sort of break the MSP M0 family down into little groups?
Yeah. I think the best way to look at it is in terms of 4 different families. So we start off in the lowest cost and lowest performance device family is going to be our MSPM0C family, and the C stands for cost leadership. Moving up, we have our MSPM0H device family. These are a newer device family for us, and it's going up from the standard 3.3 volt microcontroller up into our first true 5 volt microcontroller in our portfolio. Then one more step up, we do have our MSPM0L device family, L standing for low power in this case. These devices have standby at 1 microamp with retention, very fast wake-up times for any battery constrained applications. And then the highest performance device family in our portfolio are our MSPM0G devices. These add in some math accelerators, faster CPU frequencies, and such to help with higher level processing.
Wow, so that's quite amazing. So the MSPM0 family is really quite a broad range, despite being sort of general purpose microcontrollers. Are there similarities between the families, such as sort of a standard set of peripherals, so that, for example, I can start with a device with less memory, and then when I realize there's not enough, I can move to one with larger memory, or move from a standard device to something with higher performance if I hit the limits of the device I've started with?
Yeah, that's been something we've kept in mind since the inception of this portfolio. We wanted to make sure that we were reusing the same building blocks to scale up and down. So the same peripherals, the same communication interfaces are going to be consistent across the portfolio. And we also have within the same packages all of the devices, regardless of which of the 4 families you're working with, will be hardware and software pin-to-pin compatible. So you can just switch it in your IDE, or in this case, Zero Code Studio, switch to a different device and have that all still apply.
Well, that's really helpful, because I've worked with sort of families of microcontrollers in the past, and it's been, you've got everything prepared for one device and you move to another one, and there's some sort of variation on the interfaces, and it makes it a bit of a struggle. Now, one of the biggest sort of challenges, I think, for my generation, I'm Generation X, I had to look that up on the internet, it's about when we're sort of learning to build electronic circuits and get our first experience with a microcontroller, we always had to sort of build the circuit and solder on all the components. But my feeling is today, and from the students, engineering students I meet, they've sort of grown up with SBCs, there's lots of plug-on modules, and that sort of allows them to focus on implementing their desired application rather than fixing all those elementary errors that I always had to deal with on their PCB design. So what's Texas Instruments done around the MSPM0 family in terms of hardware to support sort of like this rapid development approach that people want with an MSPM0?
Yeah, so for our MSPM0 portfolio, each device family, each new release has its own dedicated evaluation board, or launchpad like we like to call it. I have a couple of them here with me to help for today. And these launchpads do have the superset device on the board. It has the highest amount of memory, most analog features on it, and the superset largest pin count option, so that you have all the possible features you can play with in this case. On board, there's also a XDS 110 debugger that you can use to program, flash the device, work, and debug it on that side. Fun little tip, you can even take off some of the headers and just use the debugger on its own as a standalone thing as well too, if you're building your own board. We do also have the standard, what we call booster pack header format. So we build up a ton of sensor booster packs, communication, connectivity booster packs that you can tack on top and use in tandem with our microcontrollers as well. So this is a nice first pitch and first go at it if you're interested in any of our devices.
That's great. Well, so we now have a great line of microcontrollers, and we've got a range of development boards. I guess the next questions developers are going to be asking is, how do I develop code for the MSPM0? I mean, the microcontroller-based SBCs have typically focused on C++ with a setup function and a loop for code, but I mean, you need to be relatively good at C++ programming. Lots of students these days, they're more familiar with Python, I'd say. And furthermore, the C++ compiler, that can be very challenging to understand. I mean, especially with its vague messages when a compilation fails. We're a generation or two apart, Alex, and I grew up programming 8-bit microcontrollers and assemblers. I mean, how were you taught to code microcontrollers at college or university, and what sort of dev tools do you think Gen Z engineering graduates are expecting from a microcontroller vendor these days?
Mm-hmm. Yeah, that's a very interesting question. In this case, on my side, I actually started with my Intro to Engineering course with more of a visual programming tool. Instead of going straight into C and into the nitpicky aspect of it, we took time to really build up the engineering mindset, understanding the flow of the application code. So it was just a block-based visual tool for us to program these little robots to follow lines and everything there, just to fully understand what's going on the back end before getting into that next step. And with MSP, we wanted to do something relatively similar, where we have different tools for different levels of engineers and the amount of resources that they have available, whether they want to go into all the documentation, into all the details, or if they want to do a quicker prototype or build up with more of a visual-based tool.
Wow, that's for me personally a little bit extreme. I mean, I've always been a bit skeptical about getting too far away from the code and the internals of the microcontroller. I guess it's just what I'm used to, but I mean, I have to admit as well, things move on, progress is happening, and I have to believe that Texas Instruments has chosen this development approach for a reason. Alex, perhaps you can introduce me to Zero Code Studio, but if you mind, just be gentle with me.
Of course. Yeah, let's hop on over. So here I have pulled up our MSP Zero Code Studio tool page. And this is where you can find all of the details, the downloads, and the different options for selections here for the Zero Code Studio. This can be found just on ti.com. The main reason I wanted to pull this up is to highlight that there's two different options for utilizing the tool. You can either hit launch and use a cloud version of the tool where you don't need to download anything onto your computer, and you can still flash directly to your launchpad or device of choice. On the other side, you do also have a download option where you can download and have a desktop shortcut, just make it a little bit easier for saving on your local drive. So to highlight a little bit more about Zero Code Studio, I'll go to my local drive. This is the entry view for our Zero Code Studio. You can select whichever device you're using. Right now, I have plugged in our little MSPM0C device, the smallest, lowest cost option that we have. So that's C1104. And you have different options for the starting project you can use. You can go empty if you just want a blank sandbox, or you could go into any of the pre-made examples down below. Let me just pull open the empty. Once you get that up and loading, it's a very simple process to get started with your application code. All you need to do is click on the peripheral you're interested in. Say you want to LED toggle, add that in. Where did it go? There we go. And you can pull it into the infinite loop, pick all of the selections. So the pin muxing, everything there that you're looking for. And then once you're ready to go, all you have to do is click build and load, and it'll flash directly to your device. No IDE required.
That's fantastic. So there we've got, obviously, down at the bottom, that's a little bit like the setup step, I would say, isn't it, that people use, and then you've got that infinite loop, which is common as well, where the code I want to run just keeps running in a circle, repeating forever until the power goes off.
Pretty much. Yeah. So there's technically two different aspects of this flow. So the reason it's still giving me an error is because you need to make sure that the connections are all there, so you don't have any floating blocks. They're all tied in. So say we just wanted to toggle the LED, you can put that there, go to the end. This is not a very fun demo, but this just highlights what you're able to do here. And once all of that's selected, that error should go away.
Okay, so it looks good. I was still not 100% convinced. So I'm a sort of a battle-weary developer, and I know that the challenges are often found in the details of the code. Why don't you sort of like take me now sort of step by step through some of the other sort of details that we need to consider if we were developing that classic blinky LED project?
Yeah, definitely. So the two components you would need for the classic blinky example would be just a LED toggle and a delay function, depending on the speed you want it to blink. So you can click on both of those in the far left here, add them in, and put them in order. So you can go start of the infinite loop here over into the entry of the LED toggle, and then just kind of go down the chain. And for each of the blocks, you need to help with configuring it. Since we selected the C1104 in the beginning, it already has the specific pins that the switches and buttons are already on and LEDs are already on. So if you go here, you can see that it's the C just has one LED, and that's on PA22. And then we can configure the delay to be however long we want it to be. So say we do 1,000 milliseconds in this case. And then you can see as well all of the different pin muxing and generated files. So you can see what pins are being used, if there's any errors with the selections that you've chosen. So if there's any conflicts, you can see that here. And in the generated files, you can also see in the main.c file any of the updates that have been changed live as well too. So say we go from 1,000 to 500. You can see that here. And it updates what we've been working on. And once you're ready to go, You can just hit build and load. I already have this all connected, and let's flash it.
Let's do that. So there we go. It's building the code at the minute. We've got our little moving bar at the top of the screen that's going to keep going, I guess, until it's ready. And what happens next?
Yeah, then you'll get a prompt. It'll tell you, so it's just building right now, making sure everything's good to go and there's no errors. Then it'll give you the option to flash using the XDS 110 programmer that's on the Launchpad. Once you click that, it'll go onto the Launchpad and we can see the LED blink.
And this also works straight outside through my browser as well. Is there anything I need to do in order to make it possible to use my browser as a development environment?
Yeah, so to use the browser as a development environment, we do have a add-in for TI Cloud Tools. That's the main item there. And in this case, that's the only thing you need, and nothing else is downloaded, and it'll flash directly to the device. There we go. And we have another view here, but the LED is blinking.
Oh, that's brilliant. That's I tell you what, I mean, what appeals to me is the simplicity of being able to convert my idea into a functioning application so quickly, especially in the prototyping stage. I mean, I guess, as I said, I've worked with lots of students. I've worked with lots of startups over the years, and they're more interested in getting something working than sort of fine tuning it for the final product. So, I mean, that's obviously ideal in such cases. I can just put those blocks in, link them together, and I'm ready to go. So, just another question on that process that you were talking about. What do I need to do if I now decide I want the LED to blink only when a button on the Launchpad is pressed? How would that happen?
Yeah, that's a pretty simple addition here. So in this case, we can go over into the Launchpad hardware. So on this Launchpad, we have the different LEDs that we've been using, the different switches. So this is highlighted here. If you wanted to add this in, you could just hit the on button press, add it into the loop. We'll need to reconfigure some of the connections, but it's pretty straightforward where you can just do on button press, redo the connections here. PA16 is the one that's connected on this front. And then once again, you just have to build it up and flash it. So let's do it again. Awesome. And there we go. So on the button press, it'll switch off and on again.
Oh, this is looking very clever. I mean, it's different to how I usually program and approach putting my code together, but I can see how this would allow me to rapidly optimize my design and sort of try out lots of different ideas. I guess another challenge that developers face is that they find, as I said it earlier, they find the chosen microcontroller is missing a peripheral they really need, or there's not enough memory. I mean, if that were to happen with this project, how easy is it to port this to functioning code to a more powerful, more feature-rich device from the MSPM0 lineup?
Yeah, scalability is one of our key pillars for this MSPM0 portfolio, and we wanted to pull that into the tooling as well. So it's as simple as a couple of button clicks. So as you can see here, the device view that I highlighted earlier, we have a button that you can just hit to switch. Here you can pick different boards, different devices. Say you're not using a Launchpad, say you're using a sample or an actual different IC. You can help to select the different packages that we have available here. So in this case, I do have another board with me. So I do have the low power M0L1306, and it's as simple as doing that and hitting confirm. It'll move everything over for you. See, there's some small updates and errors that come in when you do this, and that's mainly just because of the differences of the launch pads. So if you take a look at the LED toggle, PA22 was the pin for the LED on the MSP M0C launch pad. If you're doing the MSPM0L, it's a different pin. So it's as simple as going in. You can pick whichever one you want. PA0 is just a standard LED, and then we do have some RGB LED options on this one as well too. So if we wanted to pick different duty cycles and stuff as well too. So as simple as that, and we're ready to build and load again. Let me just switch it over. Awesome. So here we have the MSPM0L 1306 board. In this case, we have PA18 for the on button press and PA0 for the LED toggle. So PA18, we have two switches on this one compared to the other one. PA18 is over here, highlighted just on the silk screen, and then PA14 is the other one. So if you just hit this on, off, very simple.
Oh, I'm definitely warming to this zero code approach, Alex. I guess the thing that worries me is, like, I'm a project manager of a development team, and one of my graduate engineers are developing a prototype, but then they're sort of discovering some little niggly issue that they can't resolve at this visual coding level. Is there a way for me to sort of dig into the source code to help them out, maybe?
Yeah, for sure. So like I brought up earlier, we do have all of the generated files available, visible for you to go in and review. So if you wanted to go in, see, this is the main.c file, you can go in and see all of these, all the different interrupt handlers and everything there. And there's also all of the linker header files and everything you might need. And also, if you just wanted to export the executable, you can also do that up at the top.
Well, it's all very impressive, Alex. Thanks for guiding me through MSP Zero Code Studio and showing me how to rapidly create applications. I'll admit I don't have much time these days for coding, so it's been really great to get into the details of this new MSPM0 microcontroller family and also experience that zero code development process under your guidance. So thanks ever so much.
You're welcome. Glad I can help. Did you actually know that some of my teammates here at TI say that you can make a project in just under 10 minutes?
Really? Okay.
Yeah.
Well, I tell you what, should we have a competition?
Let's go head to head.
Okay, agreed. Right. Tell you what, right? You give me a little bit of time to dig into this myself. I'll get myself a board and we'll meet up again to see if A, I can beat the 10-minute barrier, and B, if I can go from zero to hero faster than a TI expert.
Amazing. You're on.
Okay, super. Well, thanks ever so much. We'll meet up again very shortly and go for a head-to-head.
Sounds good. Thank you.
Well, I have to say that I was pretty skeptical about the zero code approach. I mean, after all, I'm used to having my fingers on the keyboard and curating every bit of code. But I also have to be realistic. As we heard from Alex, graduates today are learning their craft and tools that allow applications to be developed by dragging and dropping blocks of functionality onto the screen and then deploying that as a program on a laptop, inside a web browser, and even on a microcontroller. And additionally, software development for embedded systems is changing. Increasingly, we're seeing developers with a physics background, a pure software development background, or even AI developers being tasked getting code to run on a microcontroller. Not everyone has time to read thousands of pages of documentation, learn the nuances of a C or C++ compiler toolchain, and do battle with yet another set of APIs just to read data from a couple of sensors and control an output. MSP Zero Code Studio is clearly a great entry point for those tasked with leveraging the capabilities of microcontrollers for the first time, or even experienced developers wanting to quickly try some ideas and figure out which microcontroller is best suited to the application they have in mind. I myself am very excited to try it all out and see what these MSPM0 microcontrollers can do, and naturally I want to give Alex a little run for her money in our little competition next time. If you'd like to find out more about the MSP M0 family and want to try out MSP Zero Code Studio for yourself, just visit ti.com/MSPM0, where you'll find a landing page with everything you need. Stay tuned for the next video where we'll see how easy it is to go from zero to hero with the MSP M0.